Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so I think I've come up with a solution to our plug problem. So, let's just get started. I'm just going to clip off the old connector. Alright. Then I'm going to put a piece of heat shrink on it to hold the braiding in place. And this is just some 3/8 standard heat shrink. Alright, just going to put this on there like that. And make the heat gun and heat her up. Like that. So once it cools a little bit, I'm going to try to push the wire through. Let me clip this off. I think I got a little too much. So what I'm doing is I'm pushing the wire up past the sleeve. And I found this works the best. Then trying to cut the sleeve, to expose some wire, because I end up just nicking the wire. And this I found seems to work the best. It is not the fastest way of getting the wire out, but it seems to work. Sometimes it just oh, there it goes. Now it's sliding out. There we go. Yeah, so you can kind of pull it down, and then when you're done, you can just kind of push it back up, and that works pretty good. So, okay, so you can see we have 4 wires. These have a fiberglass insulator, the 2 blacks and the 2 whites, and as you know, they're tied together down in the tip of the probe by the RTD sensor. And so I'm just going to strip these guys off. And as you can see, the strippers work okay. It gets, I'd say, 90% of it off. But you have to get in there and kind of clean up all the stragglers. I won't bore you with the details. I'll do that real quick, and I'll be back. Okay, I just used my side cutters. I don't remember if I said that earlier. To clean off all the little pieces of fiberglass. And I'm just going to use the vise here to kind of hold it for me so I can pre-tin the ends. And I am going to use some liquid flux to help it stick. And I am using lead-free solder. In case you're wondering, the iron is set at 275 degrees Celsius. I am leaving little blobs on the end to help with the soldering to the connector. Okay. Okay, so here's the connector. This is just a standard TRRS, and it stands for tip ring ring sleeve. It's what's on the other one as well. This one though has a plastic cover, I guess for lack of a better word, with a strain relief, and this one's fairly easy to solder. It has little tabs in there to make it easier. It does have one little pin. These little pins are a booger to solder. I've never mastered these things that have like 4 of these pins in there. And if you ever tried one, you know what I'm talking about. So, but what's nice about this is this plastic sleeve. So we've got the plastic sleeve, and then we have the heat shrink over this. So there's no way that this stainless steel braided sleeve is going to transfer any kind of noise to our sleeve pin. And this is for the sleeve pin right here, and that's what was causing the problems with the all metal ones, as you saw it earlier. So yeah, okay, I'm gonna go ahead and, I know this is kind of like a little, this is probably TMI for those that are just curious to see what the fix is gonna be, but I might peel part of this video off and make it a little tutorial for making these things, in case people ever want to make one. Okay. Okay, so and I'm going to add a little liquid flux to these guys. And if you're curious what liquid flux I'm using MG Chemicals rosin flux, non-corrosive type. I had a comment the other day on YouTube that they're saying that the liquid flux I was using was corrosive and going to cause all kinds of problems. But the one I am using is not corrosive. Alright, I'll try not to get in the way. I'm right-handed. Hopefully you'll be able to follow along. So really, I'm just going to pre-tin all the pins. So, and this is, you have to be real careful with this center pin right here. So I'm just going to try to do him first. And as you can see, I melted a little bit, but I did get a little ball of solder on there, which is good. You don't need a whole lot. Alright. And I know I kind of cheated and didn't flip this thing around. Just wanted to show you guys what I did. So I just pre-tinned both tabs, the center pin, and the sleeve connector. Alright. And the wiring order of this doesn't matter as long as it kind of got, so the way the controller is wired, it's the tip goes to the first ring, the second ring goes to the sleeve. So you want like white, black, or some combination of that. Okay. And by the way, you should always probably put this on first. I can actually get it on without I can just slide it over the meat probe, but it's just a step that you should do. Okay, let's do the fun one first. No, let's do what the backside one. I'll go ahead and flip it over for you. You can see. Like I said, it doesn't matter as long as it's staggered with this. Oh. The reason why I did that one first instead of the pin is to help give it some strength, because that center pin is just got a little tad ball of solder on it. Let's see, you guys see that okay? This needs to be a white one. See, that's all on okay. Yeah, it looks pretty good. I'll give you guys a close-up here in a minute. Now you have to remember not to touch. See, I'm getting a little bit happy. See how close I'm getting to that other one right there? Maybe you can't see it, maybe you can. But you can see, so this goes to this pin right here, this little piece of brass. You can see I kind of got over the conductor a little bit with the wire, because I wasn't paying attention to what I was doing, so I'm just going to trim a little bit of that back. Let's see, we still got a good solder joint on there. Oh, by the way, when you clamp these things, do not clamp on these rings, or on the sleeve, right? Yeah, don't clamp on these rings. You can clamp on the tip, and you can clamp on this barrel, for lack of a better, whatever this threaded connector is. But don't clamp right here, because these are hollow to allow for the center pin to go through. And you'll smash it. If you smash it, it will not ever fit in your 3.5 millimeter connector. Alright, last but not least, bottom one. And sometimes you might have to trim this a little bit. So if you're wondering why I put the solder way up there, it's so I didn't have to trim this wire back. Because if you put the solder like right down, I know it's hard to see, I apologize. If you put the solder way down here, then you're going to have a lot of excess wire. But if you move the solder way up here, you have to be careful not to get close to or get in the way of the pin or anything. I hope you guys can see this. I'll have to look at when I'm editing it, but okay, so I'm going to try to go ahead and in here with my soldering iron. There we go. Okay, hopefully you guys saw that. And so that's kind of what it looks like. Now what I'm going to do is I'm just going to push all these wires into this. This is kind of a strain relief, these little tabs right here. I'm not going to use it because of how I'm going to wire this up. Now what I'm doing is I'm just looking in here to make sure that none of the pins are getting anywhere near to each other. Okay, yeah, you can see I still have a little bit of excess right there. Hopefully it'll squish up in there. So now what I'm going to do is I'm going to squish it up in there. Yeah, see how I smash that? That's no good. Let me get this smashed. Now all I'm trying to do is get the heat shrink to this point right here. I'm not gonna use these tabs. All right, look good to you guys. All right, I'm gonna trim a little piece of wire off here. All right. So now what I'm gonna do is I'm gonna clamp on the tip right here. And I'm going to give this a quick test fit. Yep, I can get that on there okay. And you notice if you've ever built these before, there's usually an insulator sleeve in here, but to get that on and everything, you have to really cram this stuff in there. And that's a lot of times what causes the shorts. So then what people do is then they start they say, okay, well, we're going to put like heat shrink insulators, like the little plastic ones we saw on the old ones, and then they try to, shield everything from each other so they can smash it all together, and that ends up being kind of flaky, as you know. So what I'm going to do is, and I know this might look a little bit arts and crafty, but hot glue is actually a very good insulator. It's just basically melted plastic, and it also is very durable. So what I'm going to do is I'm going to squirt this hot melt glue inside and all around this. So when we assemble this thing, there is no way that you could squeeze that and cause it to short out. Alright? So first I'm just going to squirt it all off in here. so. Alright, that looks pretty good. Now what I'm going to do, to give it some strength, I'm going to start squirting the hot melt glue in this connector and I'm going to turn it and squirt it and kind of run it up here to add, this is just for strength, okay? So, squirt, turn, and squirt, turn, squirt, turn, squirt, turn, squirt, turn, and there we have it. Alright, and hopefully you guys saw that. I probably had my hand in the way. Okay, so I'm going to let this sit for a while. And when I come back, oh, by the way, yeah, so what I was doing is I was filling this whole barrel up with hot melt glue. And I tried to get some down in here as well. But I noticed I don't think I got too much down here. Like I said, it's easier to do when you're not trying to do it in the video. I can get down here and get personal with it. But anyway, we'll give it a shot here in a second. Be right back. Okay, so while I was waiting for this to cool off, I went ahead and set up a controller we can use to test it with. Yeah, so I know you guys can't feel this, but this thing is it's pretty solid. And yeah, I can see some of that glue did get down in here a little bit. Let's go ahead and plug it in and see how it works. Well, there you go. So it's showing about 79 degrees. Yeah, it's probably because I've been sitting on it, breathing over this thing. So anyway, that looks pretty good. But one of the things I wanted to show you, which is the benefit of this over the metal ones, is that now the way I build it, when I do it like this, it's going to be waterproof. So we're going to test that real quick. I'll be right back. Okay, so I got a water bottle here, and I'm just going to dump this thing in there. You guys see that okay? So I'm just going to take it out. I'm going to dry off the end. Oh, you probably can't see what I'm doing. I'm just drying off the end with my shirt. Because yeah, if this thing is wet, it's going to short inside the jack. I just wanted to show you that this part in here now is waterproof, right? Alright, let me move this before I dump it all over my bench. And as you can see, it is perfectly fine. So there you go. That is one added benefit of this rework, is that now it's completely waterproof. But yeah, this is a nice solution. It's not the prettiest solution, but it works. It's very strong. I mean, I guarantee you can yank on this thing. If you guys have ever dealt with hot melt glue, it's very strong, and yeah, you're not getting this thing apart. It's watertight. It's strong. It's a good solution. I like it. Anyway, that is it for this video. If you have any questions or comments, leave them in the comments below, and I'll see you guys later.
Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.